Hello friends, welcome to another lecture of linear differential equation of higher order. So in the previous video we have discussed how to solve equation of this form if qx is equal to q of x is equal to e to the power x. Okay, if q of x is of this form, how to solve we have already discussed. Now today we are going to discuss how to solve this equation if this q of x is of this form x to the power n or any polynomial in x. Okay, so we know how to find we know that solution of this kind of equation is given by cf plus pi, y is equal to cf plus pi, and we have already discussed how to find cf, isn't it? So I suggest you to watch all the videos added to this playlist, and links are given in the description box from the first lecture to all the lectures till now I have recorded. So now here you see the method to find pi is different for define you know form of qx. So that's why if the q of x is x to the power n or any other polynomial in x, then how to find the pi? So if we know how to find a pi, then you can solve this one. So here you see pi is given by 1 by f of d into q of x, isn't it? So in this case 1 by f of d, q of x is x to the power n, and 1 by f of d, that is nothing but f of d whole inverse x to the power n. So this is now we are going to expand this by binomial theorem. Using binomial theorem, we know that binomial theorem, this 1 plus x whole to the power n is given by 1 plus n x plus n into n minus 1 by factorial 2 x to the power 2 and so on. Okay, but here you see this x is not this one. Okay, so rather writing x, let me write d, 1 plus d whole to the power n. So not only the it depends what will be the form of this. Okay, this f of d. So we are going to express this f of d as binomial. It may take this form also in some equations, 1 plus d square minus 3d by something. It may take this form also. Okay, so then we are going to consider this one as x. That's how we will proceed. Okay, so now here you see one more thing. So if you expand in this way, 1 plus n into d plus n into n minus 1 by factorial 2 d square and so on. But here you see we are not going to take all the terms that will be obtained in this binomial expansion. So we are going to take only those terms up to which we will get the power of d is equal to the power of n or less than this one, up to x to, if here you see the power on x is n, then we are going to take only those terms where the minimum power on d is n. Okay, because you see if you differentiate suppose x to the power 3, you have x to the power 3. If you differentiate it once, d means here we know this d by dx. So if you differentiate this x cube, then you will get thrice x square, isn't it? So if you operate this one, if you operate it by d square, that means if you find a second order derivative, then what you will get, you have to differentiate it again, then you will get 6x. Then again if you operate this one by d to the power 3, that means if you find the third order derivative, then what you will get, again differentiate this one, then you will get 6. Now here you see what was the power, 3 here, x to the power 3. So up to if you differentiate it 3 times, we have got something here. Okay, so when you will differentiate it up to when you will operate this x to the power 3 by d more than 3 times, then what you will get, if you operate this one x cube by d to the power 4, that means if you find the fourth order derivative, then you will get 0. If you differentiate this 6 again, then you will get 0. Derivative of constant is 0. That's why we will ignore those terms where the power of d is greater than the power of x in this expression. So hope you have understood. Now let us start. So before we start, let me tell you again, so watch all the videos from the beginning that added to this playlist. So links are provided in the description box. So let us start now. Now let us solve this equation. Here you see, so our given equation is 3 square plus 5t plus 4y 3 minus twice x. Here this is the q of x, and here this is f of t. So this is the f of t. So our auxiliary equation will be f of m equal to 0, and that is nothing but replace the d by m here, then m square plus 5m plus 4 is equal to 0. If you solve it, then what you will get, if you split the middle term, then you will get m plus 1 into m plus 4. You know how to solve those kind of equations. Okay, so I have skipped those parts because just it is a simple factorization, isn't it? So m plus 1 is equal to 0, here m plus 4 is equal to 0, so here m will be equal to minus 1, and here m is equal to minus 4. So we have got the two roots, m1 is minus 1 and m2 is minus 4, and these are real and distinct. If these are real and distinct, so what will be the cf will be equal to c1 e to the power m1x. Here m1 is minus 1, so minus x we will get, and c2 e to the power minus e to the power m2x. So here m2 is minus 4, so we will get minus 4x. So this is our cf. Now let us find the pi. So here you see pi, that is given by 1 by f of t into q of x. So in this case f of t inverse, and q of x is here 3 minus twice x. Okay, so before doing that, let me do one thing. So yes, so f of d, here it is d square plus 5d plus 4, and we have my inverse here, and 3 minus twice x. So before you expand using binomial theorem, so let me express in this form 1 plus x whole to the power minus 1. Okay, so in order to do that, let me take 4 common. So then taking 4 common, here you will get d square plus 5d by 4 plus 1, this whole inverse, then 3 minus twice x. Now here you see this can be written as 1 plus d square plus 5d by 4 as well. Okay, so let me write that way. So let me clean this. So let me write that way. 1 plus d square plus 5d by 4. So if you expand using a binomial theorem, using this 1 plus x to the power n, that's equal to 1 plus nx plus n into n minus 1 by factorial to x square. Okay, using that n plus dot dot dot. So using this expression, here you see the maximum power on x, here it is 1, isn't it? So that's why we will take only first two terms only. Okay, because here you see here this x represents this term. Okay, don't think of this. Okay, in this case this x represents this term. Okay, so hope you have understood this in this case only. So now you see when you will expand using this this term, then what you will get, and 4 to the power 4 inverse of 4, that will be 1 by 4, and here it will be 1 plus, and here n is minus 1, so n is minus 1 here, so we will get here 1 minus, isn't it? So 1 minus d square plus 5d by 4. So here minimum power on d is 1. Okay, in the next term the minimum power on d will be square. So in the next term, if you expand this, in the next term you will get, so here it is minus 1 minus 1 minus 1, then it's going to be minus 2 minus 2 minus 1, that's going to be plus 2, and cancel it by factorial 2, then you will get x square, that means d square plus 5d by 4 whole square, that's what you will get. And here minimum power on these will be square 2. So if you operate x to the power 1 by this d square, then you will get 0. That's why we are going to take only these two terms, first two terms. Okay, we are going to ignore the remaining terms. Okay, so now let me clean this part here. Sorry. Now you see what we have taken, only first two terms. After expansion, 5d by 4 into 3 minus twice x. So here also this d square term can be ignored, so we can write as let me scroll down the page. Okay, so we can take only 1 by 4, 1 into this one will be twice, 3 minus twice x. Then let's here you see this power of d here in this case is greater than power on x, so that's why we can ignore this term, square term. So we can take only 5 by 4 d into 3 minus twice x, that's what we can take. Okay, so then you will get 1 by 4 3 minus twice x, and if you differentiate 3, then it's going to be 0. D means d by dx, isn't it? You know that. So that's going to be 0, derivative of constant is 0, and if you differentiate this minus twice x, then you will get minus 2. So minus 2, then minus 5 by 4, that's going to be plus 10 by 4. So hope you have understood this. Now what we're going to have here, if you simplify this, then what you will get. So let me simplify this one. Let me scroll down the page. So 3 by 4, so let me make it this way. So 1 by 4, take LCM, 4 12 minus 8x plus 10, and here it is 16, then 22 minus 8x. So cancelling, if you multiply half here and here, then what you will get, you can have 1 by 8, 11 minus 4x, that's what you will get. So this is our pi. So we have got cf and pi, and we know the solution is given by y is equal to cf plus pi. That's very simple, isn't it? So cf is c1 e to the power minus x plus c2 e to the power minus 4x plus 1 by 8, 11 minus 4x. So this is our solution. Okay, so link of all the lectures made on this topic are given in the description box. Please watch it from the lecture 1, then you will understand. Okay, so now let me give you another example. So let us solve this one. So here you see our f of d is d square minus 4d plus 3. This is our f of d here, and therefore auxiliary equation is f of m is equal to 0. Now replace the d by m here, so then what you will get, m square minus 4m plus 3 is equal to 0, and as it is quadratic equation, you can solve it by factorization or by using quadratic formula. So let's factorize it, and on factorizing this, you will get m minus 1 into m minus 3, that's going to be equal to 0, which implies m is equal to 1 and m is equal to 3, isn't it? So our roots are m1 is 1, m2 is 3. So these are real and distinct roots, that's why our cf gonna be equal to, so you know, c1 e to the power m1 x That means here our m1 is 1, so we have to write 1x, and c2 e to the power m2x. M2 is 3 here, 3x. So this is our cf. Now let's find pi. So how to find pi? 1 by f of t into q of x. Here q of x is here x cube. This is our q of x. Okay, so that's why what we're gonna have here, 1 by d square minus 4d plus 3 into x cube. That's what we will get. So let us take 3 common, then you will get 1 plus d square minus 4d by 3. So x cube, and this can be written as 1 by 3, 1 plus d square minus 4d by 3 whole inverse x to the power 3. So again we're going to expand this one using the binomial expansion. If you use binomial expansion to expand this, so here you can see what we will get. Let me scroll down the page. So according to binomial expansion, x plus 1 plus x whole to the power, here n is minus 1, so let me put here minus 1. So if you expand this 1 plus, then you will get minus 1 into x. Then you will get, we are going to consider this part as x in this case, x, then plus n, that is minus 1, into n minus 1, that is minus 1 by factorial 2 and x square. Then plus you will get minus 1, then n minus 1, n minus 2. So here n is minus 1, isn't it? N minus 1, n minus 2. So hope you have understood this. So and by factorial 3, then x cube. Okay, so here we are not taking this x cube as this one. Here this term is x. In this expansion we are considering that this x, here you see, let me write here y instead of x, then you will understand better. Okay, so let me x cube. So here let us represent this one by y. So then what you see, so we are going to consider only these 3 terms. We are going to get infinite number of terms, but here we are going to get take only those 3 terms, because when you cube this d square minus 4d by 3, on cubing this, here this y is nothing but this term, so you will get the minimum power on d is 3 after expanding this one. Okay, and here the power on x is 3. So if you operate this one by d with higher power, if you operate this one, if you operate this x cube by d to the power 4 or d to the power 5, then this is gonna be equal to 0. So I have already explained how it becomes 0, isn't it? So that's why we are going to take only these 3 terms, up to which we will get minimum power of d is cube. Okay, so let me take this one first. Let me clean this part. Okay, so now if we expand in that way, so what we will get, we will get pi is equal to 1 by 3. So here first is 1, then next is minus 1 into y. Here it will be minus 1 minus y is nothing but d square minus 4d by 3. Then next here you see this is minus 1, and this is going to be minus 2, and this is going to be minus 3. So factorial 3 is 2 into 3, isn't it? Oh sorry, this is not the next term, so this part is next term. Here you see this is next term, so let me write here 3. So here you see this is minus 1, and this minus 1 minus 2, so it's going to be plus 2. So on multiplication, that's going to be plus 2, and this is factorial 2 means 2 into 1, so 2 into 1, so that's going to be cancelled by this 2. Then you will get y square only. Y square means you will get plus d square minus 4d by 3 whole square. Then our next term will be, here you can see this is minus 1, and this is going to be minus 2. So let me use the reading. This is going to be -2 and this is going to be -3. So 3 means factorial 3 means 3 into 2 into 1. So here 2 3 cancel, so we have minus here, here and here, odd number of negative signs, so terms remains negative. So then we will get d square minus 4d by 3 whole cube, and let us ignore the remaining terms, then x cube. Okay, so hope you have understood. Now let me clean this part. Okay, so here you see, so pi, let me first expand the terms, expand all the terms, then you will get 1 minus, if you d square minus 4d by 3, then plus, if you expand this one, then what you will get, you will get 1 by 9 d to the power 4 minus 8d cube, then plus 16d square, then we will get minus 1 by 27. If you expand this term, you will get minus 1 by 27, then d to the power 6 minus 12 d to the power 5, then plus 48 d to the power 4, then minus 64 d to the power 3, and x cube after closing the bracket. Now let me scroll down the page. So here is the CF, let us keep it here. So now you see, let us ignore the terms which contains the power of d is higher than where the power of d is higher than this power on x. Okay, so let me ignore those terms, because when you will operate x to the power 3 by the terms of higher power, whose power is more than 3, that means 4 5, okay, so we can ignore this, ignore d to the power 6, d to the power 5 and d to the power 4. So after ignoring those, we have got pi is equal to 1 by 3. So what we will get, we will get 1 minus d square minus 4d by 3 plus 1 by 9 minus 8d cube plus 16d square. So you can multiply the x cube as well. So let me multiply this x cube with this with the terms inside the bracket. So if you do so, then you will get x cube here, then you will get d square by 3 x cube, then this is minus, so plus 4d by 3 x cube, then plus 1 by 9. So this term can be ignored, so we can take minus 8 by 9. So minus 8 by 9, d cube x cube, then plus 16 by 9 d square x cube, then what you can take minus, so here we can ignore d to the power 6, d to the power 5, d to the power 4 as well, so only this term is left. So minus 64, this is also minus 27, so it's gonna be plus 64 by 27 d cube into operates on x cube, so that's what we have got. So now you see, if you differentiate x cube, or you can write d x cube, then you will get 3x square, and if you differentiate it again, then you will get 6x, and if you differentiate it again, then you will get 6 only. So let us put those here. Okay, so here it should be differentiated twice, here once, and here thrice, and here we will differentiate x cube 2 times, and here 3 times. Okay, so then we will get 1 by 3 x cube minus 6x by 3, then plus 4 by 3 3x square, then minus 8 by 9. Here d cube, so we are going to operate it 3 times, and operating it 3 times we will get 6, isn't it? So here we have got only 6 plus 16 by 9, so 16 by 9. Here d square is there, so we are going to operate this or differentiate this twice. So if you differentiate this twice, x x cube, if you differentiate it twice, then you will get 6x. So here we will get 6x. So then 64 by 27, and differentiate x cube twice, 3 times, then you will get only 6. So that's what we have got, pi. So this is pi, and if you simplify this, then what you will get? So first let me simplify this. 1 by 3 x cube minus this in 2 times, here 3 gone, then 3 is a 9, 3 to the 6, then 3 is a 9, 3 to the 6, then here it will be 3 9 the 27, 3 to the 6, and after simplification we will get x cube twice x plus 4 x square minus 16 by 3 plus 32 by 3x plus 128 by 9. Then yes, that's it. So if you multiply here 9 and here also 9, then if you multiply this one with the terms within the bracket, then what you will get? Then you will get 1 by 27, and you will get 9x cube minus 18x plus 36 x square minus 48 plus 96x plus you will get 128. So then here you see this is 96 minus 18, then this is 128 minus 48, and then finally we will get pi is equal to 1 by 27 9x cube plus 36x square plus 78x plus 80. So we have got pi, and we have already got cf also. So this is our pi, and our cf was this one. This is our cf. So we have got cf and pi. So that's why our solution, the solution is given by y is equal to cf plus pi. So what we have got, cf is equal to c1 e to the power x plus c2 e to the power thrice x. Let me put here c1 e to the power x plus c2 e to the power thrice x. That was cf. And pi, we have got this. Let us put here 1 by 27 9x cube plus 36x square plus 78x plus 80. So that is our solution. Hope you have understood this. So I'm telling you again, please watch all the video of this playlist, and I will provide the link of all the videos on this topic. So thank you for watching, and if you like the video, hit the thumbs up button and share with your friends, and inspire me to create new videos, subscribing the channel. So see you in the next video.